I'm Anil Kumar, and now let us explore limits in further details. Here, in this example, we will start from the limits and then sketch a graph and define the function. So we'll go in the reverse order. We'll consider one-side limits in this particular case. Okay, so let us create some example for one-side limits. So let me write down the function first. Let us say we have a limit x approaches, let's say x approaches 2 for the function f of x, and let us say 2 from the left side. So 2 minus means from the left side, and the value of the limit is, let us say, 3. And limit x approaches 2 from the positive side, and let us say this limit is 0. And we can also take the value of the function at this point. So let's say that the value of the function at 2 is equal to, let us say, 1. Now in this particular case, what is the graph of the function? What could be the graph of the function representing this situation? That is our question. And once we get to the graph, we'll write down the equation of that particular graph. So let's begin by sketching a graph for the given situation. So that is our x and y axis. And what we are given here is that as you approach 2 from the left side, then the limit is 3. So what we will do here is we'll make a scale 1, 2, 3, and here is a 1, 2, 3, let's say. Okay. So when you're approaching 2, so this is 2. When you're approaching 2 from the left side, the limit is 3. That means from the left side, you are approaching a point whose value is 3. Make a hole at that point. Normally, whenever there is a limit, we are approaching that point. We are not at that point. So making a hole is not a bad idea. Second, I will, in such cases, whenever one-side limits are there, use horizontal lines or y equals to whatever the value is as your function. So that will help you to make an easy graph. So we have limit as x approaches 2 from left side is 3. So at 3, I'll make a horizontal line going in this direction. So on the left side of 2, the value of the function is 3. Now the second part is on the right side, limit is 0. That means as you approach 2 from the right side, you are approaching 0. So we'll draw a horizontal line in that direction. Do you see that part? Correct. And the third part which connects this is the value at 2 is 1. So really the value is 2. So 2 is 1. So that is 1 for us. So that gives you one possible graph. There could be more than one graph to represent the same situation. Correct. Let me label it now. So that is how it is. And we're talking about the function f of x. Once you have your graph, you can actually define. So let me define it now. So we can say f of x is equal to, so we'll make it 3 pieces, correct? 3 pieces. So the first piece is equals to 3 when x is less than 2, right? So when x is less than 2, it is 3. And then we say if it is equals to 0 when x is greater than 2. So that is this part, right? And it is equal to 1 when x is equal to 2. So that is how you can easily define your function, right? So I hope that helps. So these are very simple steps which will help you to answer such questions, howsoever difficult it may be, right? You can always give combination of these equations when you have limits from left side and right sides different, right? So that is how you should be doing it. Now let me take one more example, and that is, this time we will say, if the value of the function is given to us and the limit is given from one side, okay, so what we say is, let us say that the value of the function f of x is equals to 1, and that too when x is, let us say, less than 1. So whenever x is less than 1, the value of the function is 1. However, we say limit of the function f of x as x approaches 1 from the right side. So we are giving limit from the right side. So let that limit be not 1 but something else. Let us say 2, right? In this case, what are you going to do? So we'll follow the steps which we did last time, right? You can also pause the video, sketch, and then just check with my answer, but your answer can be very different and correct, right? So first part is that the value of the function is 1 when x is 1. So we don't have much option here. We have actually one part of the function defined. So when x is, this is 1 for us. So less than 1 means that is not included, and this value is 1, so that means it is a horizontal line going like this, right? So this is your function part. Is it okay? Now the second part is that the limit is different. 1 plus, that means if you approach 1 from the right side, you will end up at 2, right? So what we do here is, so at 2 we could have a function starting like this, and it could be a straight line like this. Do you see? Likewise, or you could draw a horizontal line like this also. Your wish, correct? So I'm just giving you a variation this time, and so that works. Now here we have an option. You could make it filled in also, right? Or you could define the function in 3 pieces. That is up to you. So anyway, if we draw this kind of a function, then we say f of x is equal to 2 pieces for us in this particular case. It is not defined at 1, you can see that. So it is equal to 1 for x less than 1. That is given to us, right? And what happens when x is greater than 1? If x is greater than 1, then the point is at 1, 2. So the slope is 2, right? So we'll say 2x. 2x when x is greater than 1. If some of you decide to fill in this gap here, right, in that case this becomes greater than equal to, right? So I hope from this video you learn how to sketch the graph of a function and how to write equation for the function once the limits are given to us. Thank you and all the best.